Let me ask you a question. What is the most deceptive object in the night sky? You might guess something exotic. A quasar masquerading as a star, a black hole bending light around itself so you see what isn't there. Perhaps a distant galaxy whose light has traveled so long that what you're seeing no longer exists. But no, the answer has been hanging above your head since before you were born. You've wished upon it, you've written poems about it, you've watched it rise orange and enormous over the horizon and felt something ancient stir in your chest. It's the moon, that pale, familiar, beautiful disk. And I want to tell you something that may disturb you. The more I have studied what it would actually mean to live on the moon, not visit for 3 days like the Apollo astronauts, but actually live there, build a settlement, raise a generation, make it a home, the more unsettled I have become, because the moon doesn't just present challenges. It presents challenges that are, in several profound ways, designed by 4 billion years of physics to be specifically, personally, intimately hostile to anything with a heartbeat. The dangers don't announce themselves with explosions or fire. They're quiet, they're cumulative. They work in silence, at the molecular level, inside you, and by the time you notice them, they are already doing their work. So by the end of today, I want you to understand something that most space enthusiasts never think about. I want you to see that the moon, this object we've gazed at since we first stood upright, is not a hard engineering problem waiting for clever solutions. It is a biological incompatibility written into the fabric of physics itself, and I want you to understand why. When you really dig into the science, the explanation is beautiful, but deeply unsettling, because it means that you, a creature assembled by 4 billion years of evolution on a living, cycling, forgiving planet, are fundamentally unsuited to exist on a world that forgot how to heal itself 3 billion years ago. A world that has done nothing since then but accumulate wounds. All right, let's start with something that sounds absurdly harmless. Dust. You've seen dust your entire life. It settles on your bookshelf. It drifts through a shaft of light near a window. It gathers in corners. It's so ordinary you don't even think about it. You'd never dream of calling it remarkable. You'd certainly never call it a weapon. But let me tell you, if you showed a biologist from another planet, a biologist who had studied every substance on 1,000 different worlds, but had never encountered lunar regolith, a handful of moon dust, that biologist would recoil in horror. That biologist would look at you and say, "This is not dust. This is a slow-acting poison, optimized by physics to destroy biological tissue. Why would you touch this? Why would you breathe near this?" And the alien biologist would be absolutely right to be horrified, because here is the rule that virtually every dusty surface in the universe follows. When rock gets ground up over millions of years, the tiny particles that result become round and smooth. Water dissolves the sharp edges. Wind tumbles the grains against each other. Chemistry alters the reactive surfaces. Time makes dust safe. Think about beach sand. It has been tumbled by water and wind for millennia, worn down to gentle, rounded grains. You can pour it over your head, rub it on your skin, even accidentally inhale a small amount. Irritating, perhaps, but fundamentally harmless. That sand has been weathered. Time has forgiven it. The planet has healed it. Lunar dust says, "Not me." When a micrometeorite, a tiny cosmic pebble moving at 20 kilometers per second, that's 70 times the speed of a rifle bullet, strikes the moon, it doesn't bounce. It doesn't chip the rock. It vaporizes on impact. The energy is so extreme that it melts the surrounding surface instantaneously. That molten material, a plasma of silicates, metals, and glass, splashes outward in the vacuum. With no atmosphere to slow it, no wind to scatter it, it flies until it lands, solidifying in mid-flight into tiny shards of glass. And then those shards sit there for millions of years until the next micrometeorite hits them, shattering them into smaller fragments. And those fragments are hit again and again and again for 4 billion years until the surface is not soil, not sand, not dirt, but a nanoscale powder of angular, jagged, razor-edged glass. Under an electron microscope, lunar dust doesn't look like sand. It looks like broken safety glass from a car crash, shattered into infinite recursive angles. Every particle, a geometric knife. Every grain, a weapon. Now I said, that sounds like an engineering challenge. Better filters, better suits, better airlocks. Let me show you why it is anything but an engineering challenge. Let me show you why it is a temporal problem, a problem of time itself. On Earth, when you inhale a harmful particle, your immune system responds. Macrophages, the cellular cleanup crew of your body, engulf the particle and destroy it. Or if they can't destroy it, they wall it off, isolate it, neutralize the threat. Your body heals. The damage is temporary. Lunar dust doesn't play by these rules. The glass shards are the wrong shape. They're jagged at the nanometer scale. When a macrophage engulfs a lunar particle, the particle shreds the macrophage from the inside. The cell dies. Dying cells release inflammatory signals. More macrophages arrive. They also die. The inflammation becomes chronic. Scar tissue accumulates in your lungs. This process has a name: silicosis. Coal miners developed it from terrestrial silica dust over decades of exposure. But lunar silicosis would be faster, more aggressive, more irreversible, because lunar particles are sharper than anything on Earth, more chemically reactive, and they never dissolve. And it gets worse. The nanoparticle fraction, particles smaller than 100 nanometers, smaller than a virus, doesn't stay in your lungs. It's the right size to pass through the alveolar membranes into your bloodstream. It can travel anywhere. Your liver, your heart, your brain. Rodent studies using similar nanoparticulates show cognitive decline, memory impairment, increased markers of neurodegeneration, not from a disease, from the physical presence of glass in neural tissue. And here is what should truly disturb you. The damage is cumulative. It doesn't heal. The moon doesn't heal, and your lungs can't heal fast enough to keep up. A 3-day Apollo mission caused Harrison Schmitt, the only geologist to walk on the moon, to sneeze for hours, eyes watering, nose running, what he called lunar hay fever. A transient irritation reversed when he left. But he was only there for 3 days. What happens after 6 months? After 2 years? After 10 years? We don't know. No terrestrial analog exists. No human has ever been exposed to pristine lunar regolith for longer than 72 hours. But we know this. The moon has been sharpening its dust for 4 billion years. Your body has been evolving to handle rounded, weathered, Earth-softened particles for maybe 400 million years since lungs first appeared. The mismatch is absolute. You are not fighting a substance. You are fighting geological time itself. But the moon doesn't stop there with just one act of hostility. Let me tell you about the radiation. Here's a fact that should bother you more than it probably does. Standing on the moon's surface, you receive approximately 380 millisieverts of ionizing radiation per year. That number alone means nothing until you know what surrounds it. On Earth's surface, you receive roughly 3 millisieverts per year from natural background sources. Cosmic rays filtered through the atmosphere, trace radioactive elements in soil, radon gas. On the International Space Station, partially shielded by Earth's magnetic field, astronauts receive about 150 millisieverts per year. On the moon, you get 380, more than double the ISS, more than 100 times Earth's surface. Now, do you know how absolutely insane that number is? The legal occupational exposure limit for a nuclear power plant worker, someone who works around fissile material for a living under strict regulatory oversight with dosimeters and health monitoring, is 50 millisieverts per year. A moon resident would exceed the nuclear industry's annual safety limit in approximately 7 weeks. But here is where the horror really begins, because the number, 380 millisieverts, is just the dose. The real problem is the quality of the radiation. Galactic cosmic rays aren't X-rays. They aren't gamma rays from some decaying nucleus. They are matter. Actual atomic nuclei stripped of their electrons and accelerated to nearly the speed of light by supernovae and black holes across the galaxy. Protons, helium nuclei, and the really nasty ones, heavy ions, iron-56, silicon-28, calcium-40, the debris of dead stars flung across the cosmos for millions of years until they find you. When a heavy ion, say an iron nucleus carrying 26 protons, passes through your body at relativistic speed, it doesn't create a simple break in your DNA. It creates a cylindrical track of absolute devastation. Let me build this up carefully because it deserves to be understood. The iron nucleus carries an enormous positive charge. As it screams through your tissue, it strips electrons from every atom in its path. Those liberated electrons, called delta rays, carry enough energy to ionize thousands of water molecules. And your cells are 70% water. When water is ionized by high-energy electrons, it splits into hydroxyl radicals, O, with an unpaired electron, the most chemically aggressive molecule known. A hydroxyl radical will attack the first stable molecule it encounters. It doesn't care if that molecule is part of your DNA, because the iron nucleus is so massive and so fast, it creates not a single point of damage but a dense, continuous column of ionization, a delta ray track, perhaps 10 to 20 micrometers long, containing thousands of hydroxyl radicals, breaking DNA strands, oxidizing proteins, shredding lipid membranes. On Earth, your DNA sustains about 10,000 breaks per day from normal metabolic chemistry. Your repair enzymes find the breaks, cut out the damaged section, stitch it back together using the complementary strand as a template. The system works because the damage is sparse. One break here, another break there, each one isolated, each one fixable. Inside a delta ray track, the damage is clustered. Multiple double-strand breaks, base oxidations, and cross-links occur within a few nanometers of each other. The repair enzymes arrive and they cannot parse the damage. They cannot tell where one break ends and another begins. They attempt to reconstruct the sequence, but they have to guess, and they guess wrong. The result isn't just a mutation, it's a chromosomal catastrophe. Deletions, inversions, translocations, and in neurons, which don't divide and replace themselves, these errors simply accumulate, permanently, for life. Animal studies, firing accelerated iron nuclei at mouse brains, show cognitive impairment, memory loss, increased anxiety-like behavior, at dose levels achievable in a single year on the lunar surface. The radiation isn't just raising your cancer risk, it is slowly and steadily degrading your capacity to think. And here is what should genuinely terrify you. You cannot engineer your way out of this. Your instinct is to add shielding, thicker walls, more material between you and the particles. But high-energy heavy ions, when they strike dense material like aluminum, undergo nuclear spallation. The incoming nucleus shatters, creating a shower of secondary particles, neutrons, pions, lighter nuclei, that spray in all directions. Some of these secondaries are more biologically damaging than the original ion. Add thick aluminum shielding, and in some geometries you don't reduce the biological dose, you increase it. The physics is working against you. The only effective shielding against galactic cosmic rays is several meters of hydrogen-rich material. On the moon, in practical terms, that means burying your habitat under several meters of lunar regolith. The same substance that is trying to destroy your lungs is also your only defense against the substance trying to destroy your brain. This is the moon's idea of a joke. But wait, I haven't told you about gravity yet. The moon's surface gravity is 1/6 of Earth's. You'd weigh 12 kilograms instead of 72. You could jump 6 times higher. You'd feel light, free, almost floating. People hear this and think it sounds wonderful. Your skeleton doesn't think it sounds wonderful. Your skeleton thinks it sounds like unemployment. Bone is not a static structure. It is living tissue, continuously remodeled by two competing cell populations. Osteoclasts break down bone. Osteoblasts rebuild it. The balance between them is calibrated across 4 billion years of evolution to the mechanical load imposed by Earth's gravity. Stress the bone and osteoblasts activate, adding material. Remove the stress and osteoclasts dominate, removing material. The system is elegant. It matches structure to need. Reduce the gravitational load to 1/6, and the osteoblasts receive a clear signal. We are not needed here. They slow down. The osteoclasts, indifferent, keep working. The net result, bone mineral density drops. In full microgravity, the loss rate is 1 to 2% per month in weight-bearing bones. On the moon, with 1/6 gravity, the loss would be slower, but it would be persistent, year after year, cumulative, irreversible even if you return to Earth. After 5 years on the moon, your femurs might have the density of wet chalk. A stumble on a flat surface could shatter them. And it isn't just bone. Fluids in your body, no longer pulled firmly toward your feet, redistribute upward. Intracranial pressure rises chronically. The optic nerves, delicate cables connecting your eyes to your brain, swell under sustained overpressure. Spaceflight-associated neuroocular syndrome, SANS, causes structural changes to the eyeball, choroidal folds, reduced visual acuity. Roughly 40% of long-duration ISS astronauts show measurable eye damage, some of it permanent. We didn't know to look for this until we started keeping people in space long enough for it to manifest. What else aren't we looking for? Now let me tell you about temperature. The moon's surface temperature ranges from plus 127 degrees Celsius in direct sunlight to minus 173 degrees Celsius in the lunar night. A swing of 300 degrees, twice a month. Let me put that in context. The most extreme temperature range ever recorded on Earth's surface, from the hottest Saharan noon to the coldest Antarctic winter, is roughly 130 degrees over the course of a year. On the moon, you get more than twice that swing every 2 weeks. And here's what makes it truly extraordinary. A lunar day is 14 Earth days. A lunar night is 14 Earth days. There's no thermal buffer, no atmosphere to trap heat, no ocean to absorb energy during the day and release it at night. The surface heats and cools directly, immediately, in exact proportion to sunlight exposure. Nothing in between, nothing to moderate. Your habitat's outer hull cycles through 300 degrees of thermal stress every 4 weeks. Every seal, every structural joint, every material interface, being stress tested in ways that have no terrestrial analog for as long as the structure stands. In the permanently shadowed craters near the lunar poles, temperatures fall to minus 240 degrees Celsius. Colder than Pluto, on the same body that reaches plus 127 in full sun. Now let me tell you about what's falling from the sky. Every day, approximately 100 tons of cosmic material enters Earth's atmosphere. Grains of sand, pebbles, fragments of asteroids. You see the evidence sometimes, a shooting star streaking across the night sky. What you're seeing is a death. A cosmic particle, perhaps the size of a sand grain, has just been incinerated by friction with the atmosphere. Moving at 20 kilometers per second, it hits the air like a wall. The kinetic energy converts to heat. The particle burns. What might have struck the ground with the energy of a bullet becomes a harmless flash of light, 80 kilometers above your head. The atmosphere is Earth's probability filter. It converts near-certain impacts into near-zero surface strikes. The moon has no such filter. Every grain arrives. At 20 kilometers per second, a particle the size of a rice grain carries the kinetic energy of a rifle bullet. There's no warning, no sound in the vacuum, just a sudden puncture through a habitat wall, a suit joint, a window. And the universe has been throwing these particles for 4 billion years. It will never stop. Over years, the statistical probability of a damaging strike approaches certainty. A habitat on the moon is not a house, it's a target. And finally, let me tell you about time itself, your circadian biology, the internal clock governing your sleep, your hormone cycles, your immune function, your cognitive performance, is calibrated to a 24-hour cycle. Light and dark alternating roughly every 12 hours. This isn't a preference, this isn't a cultural habit. This is deep evolutionary programming written into your genome across hundreds of millions of years. On the moon, the light-dark cycle is 29.5 Earth days, 14 days of continuous light, 14 days of absolute darkness. There is no natural signal your body can use to maintain a 24-hour rhythm. Chronic circadian misalignment, studied extensively in shift workers, correlates with metabolic syndrome, cardiovascular disease, immune suppression, depression, accelerated cognitive aging. Your body expects Earth's rotation. The moon offers no rotation your body can use. Now let me take stock. We have dust that accumulates in your lungs and never leaves. Radiation that accumulates in your neurons and never heals. Bone loss that accumulates in your skeleton and never reverses. Temperature cycles that stress your habitat without pause. Micrometeorite probability that increases every day you stay. Circadian disruption that degrades your biology continuously. Do you see the pattern? Every single hazard on this list shares one characteristic. They are all cumulative. They all move in one direction. They all get worse with time. And here is the question that any self-respecting scientist must ask. Why? Is this a coincidence? 6 separate bad things that happen to all work the same way? Or is there a deeper structure? This is the beautiful part. There is a deeper structure. And it has nothing to do with magnetic fields or dead cores or any single mechanism. It has to do with the fundamental difference between two kinds of worlds. Earth is a cycle. Think about what that means. On Earth, water evaporates from the ocean, forms clouds, falls as rain, flows through rivers back to the ocean, and evaporates again. The cycle repeats. The water is renewed. The dust in your air settles to the ground, washes into streams, rounds in riverbeds, gets buried, compressed, heated, melted, erupted through volcanoes, weathered again into softer forms. The cycle repeats. The surface is renewed. Your body participates in this cycling. You breathe air that plants have exhaled. You drink water that has passed through a million other organisms. You eat food assembled from atoms that were once part of dinosaurs, of ancient ferns, of bacteria that lived before multicellular life existed. Your DNA breaks 10,000 times a day and is repaired 10,000 times a day. Damage and repair. Damage and repair. The cycle continues. Earth heals. The moon is an accumulation. Nothing on the moon cycles. Nothing heals. Nothing is renewed. The dust only gets sharper because every impact shatters what was already shattered and nothing rounds it back. The radiation damage only adds up because there's no magnetic field to deflect the particles and no atmosphere to absorb them. The temperature stresses only continue because there's no thermal buffer. The bone loss only progresses because there's no gravity to signal the osteoblasts. The circadian drift only deepens because there's no natural day to reset the clock. The moon ran out of internal heat 3 billion years ago. Its core solidified. Its magnetic field collapsed. Its volcanism stopped. Its ability to renew itself, to cycle, to heal, to start over, ended. And since then, it has done nothing but accumulate damage. Every micrometeorite impact preserved in the regolith. Every cosmic ray strike preserved in the crystal structure of the rocks. Every wound unhealed. Every scar permanent. The moon is a museum of violence. For billion years of violence, preserved perfectly, because nothing has ever cleaned it up. And now we propose to put human beings there. Creatures built for cycles. Creatures whose every cell expects damage to be followed by repair, stress to be followed by rest, night to be followed by day. Creatures who are, at the deepest biological level, incompatible with a world where time moves in only one direction. You cannot engineer your way out of this incompatibility. You can build better filters, but the history of 4 billion years of kinetic sharpening is embedded in every grain. You can build thicker walls, but the physics of spallation often increases the radiation dose. You can simulate 24-hour lighting, but the psychological weight of knowing you're on a dead world, in a sealed bubble, 3 days from the nearest rescue, erodes even the best simulation. You can add artificial gravity centrifuges, but we have no closed-loop life support systems that work for decades. The moon doesn't present its hazards one at a time, politely. It presents them all at once, and they compound. Radiation suppresses your immune system, which makes you less able to clear the dust particles accumulating in your lungs. Bone loss reduces your capacity for exercise, which is the primary mitigation for cardiovascular deconditioning. Circadian disruption impairs your sleep, which impairs your cognitive function, which is already being degraded by cosmic ray damage to your neurons. This isn't a checklist of problems to be solved sequentially. This is a systemic incompatibility between a cycling organism and an accumulating world. Now, here's what I find most extraordinary about all of this. We look at the moon and we see a destination, a place to go, a problem to solve. We say, Antarctica is hard, but we built bases there. The deep ocean is hard, but we sent submarines. The moon is hard, but we'll figure it out. But Antarctica has atmosphere. It has a 24-hour day. It has weathered dust. It has Earth's magnetic field. It has rescue helicopters that can reach you in hours. Antarctica is hard, but it's hard within the envelope of Earth's protective systems. The moon is outside that envelope, completely outside. The moon is what the universe looks like when you remove every system that makes biology possible. And here is the thought that haunts me. We talk about colonizing the moon, but what does that actually mean? If we build a sealed habitat, buried under meters of regolith for radiation shielding, with perfect filtration systems capturing every nanometer particle, with closed-loop life support recycling every molecule of air and water, with artificial gravity centrifuges spinning to simulate Earth's pull, with circadian lighting programmed to a 24-hour cycle, with airlocks that never let a single grain of lunar dust inside. If we build all of this, a perfect bubble of Earth transported across 384,000 kilometers of vacuum and deposited on the gray surface of a dead world, have we colonized the moon? Or have we simply built Earth inside a rock? If living on the moon means never touching the outside, never breathing the local atmosphere, because there is none, never walking on the surface without a suit that's slowly being abraded by glass knives, never looking at a sky without a helmet between you and the vacuum, then what exactly have we colonized? We haven't adapted to the moon. We've brought Earth with us, at enormous cost, and pretended the gray wasteland outside is a home. And if that's the definition of success, building a portable Earth and calling it a colony, then perhaps the moon is teaching us something we didn't expect to learn. Not how to live in space, but how utterly, completely, fundamentally dependent we are on the living, cycling, healing systems of our home world. The moon is a mirror. It shows us what Earth would look like if its core died, if its cycles stopped, if its protective systems failed. It shows us what normal looks like in this universe. Airless, radiation-soaked, thermally violent, chemically hostile, biologically indifferent. Earth is the freak. Earth is the anomaly. Earth is the one place in a trillion where the dice came up exactly right, for 4 billion years running, and the moon hangs in the sky every night to remind us how easily it could have been otherwise. So here is my question for you, and I genuinely want you to sit with it. If we solve every engineering problem on the list, perfect dust filtration, underground habitats with meters of shielding, closed-loop life support, artificial gravity, pharmaceutical bone preservation, full-spectrum circadian lighting. If we build a bubble of Earth so complete that a person inside could live for 10 years without knowing they're on the moon, have we made the moon habitable? Or have we simply admitted that the moon is uninhabitable, and the only way to survive there is to never actually be there, to live inside a simulation of the world we left behind? And if the answer is the latter, if the moon teaches us that we cannot live on a dead world without bringing a living world with us, then perhaps the most important thing the moon offers is not a colony, not a resource, not a stepping stone to Mars. Perhaps it is a warning about what happens when cycles stop, when healing ends, when damage only accumulates. A warning written in gray rock and ancient glass and 4 billion years of unfiltered cosmic violence. The next time you look up at that pale disk, when you see it rising orange and enormous above the horizon, or hanging white and silent in the winter sky, or reflected in water on a quiet night, I want you to see it differently. I want you to see what it actually is. A record of what Earth could have been. A demonstration of what Earth is shielding you from. A reminder that your planet is working for you every second of every day, in ways you have never noticed and never will. The magnetic field you cannot see is deflecting particles that would be rewriting your DNA. The atmosphere you breathe without thinking is filtering radiation and burning meteors and moderating temperatures. The weathering you never notice is rounding the minerals that enter your lungs into shapes your body can handle. The gravity you take for granted is maintaining the architecture of your skeleton and the pressure in your skull. The rotation you sleep through is providing the light-dark cycle your circadian biology requires. All of it, all the time, for your entire life. The moon offers none of this. The moon is what existence looks like without protection, without cycles, without healing, without forgiveness. And the moon is not unusual. The moon is ordinary. The universe is full of moons, airless, radiation-soaked, thermally violent, chemically hostile, biologically indifferent. That's the default. That's normal. That's what happens when a world runs out of the internal heat needed to keep its systems alive. There is exactly one place in the observable universe where you are known to be safe. You are standing on it, and 384,000 kilometers away, visible on any clear night, there is a gray and silent world that exists specifically to remind you how extraordinary that safety is. Look at it. Feel the distance. Feel the silence. And then feel, perhaps for the first time, what it means to be home. Because here is the final question, the one that matters most. What are we doing to keep Earth cycles alive? If we break them, if we stop the healing, we don't need to go to the moon to find a dead world. We will have made one right here.